You updated the configuration. You applied the config map. Kubernetes accepted the changes, but your application still behaves exactly the same. No crash, no errors, no restart. And this is where Kubernetes becomes dangerous because now your application is running with stale configurations. The YAML has changed, but the app never updated. And in production, this causes old feature flags, stale API endpoints, broken environments, and failed rollouts. Hi, I'm Shivam, and this is the part 5 of Kubernetes debugging series. Today, I will show you why ConfigMap updates sometimes does not update your application, and the difference most engineers completely miss. In the last video, we saw Kubernetes networking failures like DNS issue, service discovery, and broken endpoints. But today's problem is even more subtle because now pods are healthy, containers are healthy, and your application is running. But the application still uses old configurations. And the dangerous part? Most engineer thinks I have updated the config map, so my app should update automatically. But Kubernetes configuration behaviors depends entirely on how config map is injected. And this is where production confusion begins. Let's break this on my local Kind cluster. Before we get started, I have one small request. If you have been finding these videos helpful, I would really appreciate you subscribing to my channel. It's a simple way to support my work and it encourages me to keep creating more contents like this. Now let's jump onto the video. So as we can see, this is my cluster. I have one control plane node and two worker nodes. Let's create a config map and a deployment in appconfig.yaml file. I have already written the contents of this file. Let me copy that and we will go over it one by one. So as we can see, we have two resources in one file. The first one is a config map. The name is appconfig and it is having a key value pair which says app mode equal to production v1. And the second kind of resource we have is a deployment. The name of the deployment is config demo. It has one replica. It is using a busy box image, and this command over here prints our key value pair which is configured in appconfig after every 10 seconds. And if you note here, we are injecting our config map as environment variables using config map key reference. So let me save this and we will apply this config map. So it says our config map and our deployment has been created. Let's check our pods. It says our pod is up and running 12 seconds ago. Now let's try to check the logs for our deployment. As we can see, it is printing our key value pair which is app mode equal to production v1 after every 10 seconds. So clearly our application is reading configurations from our config map. Config map stores external configurations, for example, environment variables, feature flags, API URLs, or application settings. An important production principle is we should always separate configuration from container image. So instead of rebuilding Docker image, we just update configurations independently. Now let's try to simulate a production config change. I'm going to stop this. I'm going to clear my screen and I'm going to edit our config map. Now instead of v1 app mode equal to production v1, I'm going to make it to app mode production v2. I'm going to save it. I'm going to apply our config map changes. It says config map has been configured and our deployment is unchanged. Now let's try to verify whether our config map has updated or not. As we can clearly see, it says app mode equal to production v2. This means that our config map has been updated. Now let's try to check the application logs once again. We can clearly see even though our config map has been updated with production v2 value, our application is still producing app mode equal to production v1. Let's wait for a couple of seconds to verify if our app picks up this new value. So even after waiting for a minute, our application is still using old configuration. This is one of the most confusing Kubernetes behavior. Let me stop this. I'm going to clear the screen. Now let's try to understand why this happened. This happened because environment variables are loaded only during container startup. When containers are started, Kubernetes injected app mode equal to production v1 into the process environment. But after the process started, environment variables do not dynamically refresh. So even though the config map changed, the running container still holds the old value in memory. A critical production understanding here is config map update is not equal to application reload. Kubernetes updated the config map object, but Kubernetes didn't restart your application automatically. If you remember, when I applied our config map changes, it mentioned that config map has been configured and our deployment was untouched. So this clearly states the fact that even though we updated the config map, but Kubernetes didn't restart our application, and this surprises many engineers in production. But here is the interesting part. What if we mount the config map as a file instead of environment variables? Does Kubernetes behave differently? Yes, definitely yes. And this is where things become really important. So I'm going to create a config file named mountedconfig.yaml. I have already written the contents of this file. Let me copy this and we will go over this one by one. As we can see, I again have two resources in one file. The first resource is ConfigMap. The name of the config map is mountedconfig, and this time I'm using app mode equal to mountedconfig production v1. The second resource is a pod. The name of the pod is mountedDemo. It is using a busybox image, and it is again printing our config map value after every 5 seconds. And if you see this, this is where things get interesting. This time I'm mounting our config map as a volume. So let's go over this YAML configuration once again. I'm going to explain each and every line of code in detail. So this args means argument. These are the arguments passed to the container startup command. The command sh-c means Kubernetes runs as shell command, and whatever comes inside arguments gets executed by the shell. This while equal to true creates an infinite loop unless and until we manually stop this. An important thing to note here is if the process exists, container also exists. So we keep the process alive intentionally. This cat statement prints whatever is present inside app.properties file, and it prints after every 5 seconds. One important thing to note here is that this line is not present inside the container image. This comes from config map mount. So the application is continuously reading configurations from the mounted file. This is the key reason why config updates become visible later. This sleep 5 means print the contents of this file every 5 seconds. This is the external storage into the container. So here is an important mental model. Containers are isolated, so Kubernetes must explicitly mount external data into them. That's what volume mount does. This name equal to config volume specifies the name of the volume, and this mount path specifies where inside the container this volume will be mounted. So if we go inside the container, this volume is mounted at /config directory. Now this volume defines what storage to attach. The name is config volume, so this name should match with this volume mount name. That's how Kubernetes connect the mount point with the actual data source. The source of this volume is a config map whose name is mountedconfig as we created here. Kubernetes converts config map data into files automatically and injects into the container file system. An important understanding here is the application is not reading environment variables anymore. It is continuously reading a mounted file. And because Kubernetes can dynamically refresh mounted config files, the application eventually sees updated values without restarting the pod. This is the big behavior difference between config map as environment variables versus ConfigMap as mounted files. Now let me save this file and I'm gonna apply this. It says our config map and pod has been created. Let's check the logs of our pod. As we can see, it is printing mounted config production v1. Now the config map is mounted as a file compared to our previous deployment where it was mounted as environment variable. So I'm gonna open another git bash tab and I'm gonna run this same command in another git bash tab. Great, it is running. Now I'm gonna keep this running for some time. I'm gonna exit out from here. I'm gonna clear the screen. Now once again, let's go ahead and update our config map. This time, I'm gonna update my config map from production v1 to production v2. I'm gonna save it. I'm gonna reapply our changes. And it says our config map has been configured. Now let's have a closer look at this tab. As we can see, we did not restart the pod, but our application is reading our new config map value from production v1 to production v2. This clearly states that mounted config maps behaves differently because Kubernetes updates the mounted files dynamically. So file contents refreshes, mount volume updates, and application can see the new values, but only if the application rereads the file. Now, here is the dangerous production truth. Many applications read config once during startup, then keep values in memory forever. So even though Kubernetes updated mounted files, your application may still uses stale configuration. This causes old feature flags, stale credentials, outdated endpoints, and incorrect runtime behavior. And engineers becomes confused because the config map updated successfully, but the app behavior never changed. So the safest production approach is usually restart the deployment after config map changes, then run this kubectl rollout restart deployment. Now check pods using kubectl get pods command, and then finally check logs using kubectl logs command. Now the application finally loads the new configuration. Whenever application loads config map as environment variables, restart is required. This is a very important production rule. In production, this issue causes massive confusion because config map updated successfully, Kubernetes accepted the update, YAML looks correct, but your application silently continue using stale values. And debugging becomes painful, especially with feature flags, API endpoints, secrets, database URLs, or microservice configurations. So now you understand something critical. Config maps are not magical. Environment variables are static after startup. Mounted files can refresh dynamically. Applications must reload configs themselves, and sometimes restart is the safest option. Kubernetes updated the configuration, but application never reloaded it, and that difference matters in production. So now you have seen what happens when application keep using stale configurations. But here is an even more dangerous production problem. What happens when the configuration is a secret? It could be database passwords, API tokens, or cloud credentials. And suddenly the secret is missing. The pod starts, but the application completely fails. In the next video, I will show you how Kubernetes secrets actually work, how one missing secret can break production instantly, and why secret injection failures are extremely dangerous. That's it for today. I will see you in the next one. Till then, keep learning.